Hi guys, good morning. Welcome back to our next lecture of our Baap graph series. Basically, in the last lecture, we saw about to find a cycle in an undirected graph. Just a quick follow-up for that is to find a cycle in a directed graph. So for sure, initially we have some questions which you can do. But now, let's see. If we have given this graph right here, so basically let's assume that this graph would be given to you and you are said to find a cycle in this graph. Firstly, just pause the video and tell me where is the cycle you can find in this graph. Firstly, it's a big deal to find a cycle in the graph which is directed, because earlier in the undirected graph what we knew was, okay, we can just go from here to here to here. Okay, we found this cycle, cool. We found here a one cycle, cool. Here we found one cycle, cool. But here if you just closely see, then you will see you will go from here to here to here, stop. Go from here to here to here, stop, because we can't go up here, we can't go down. So okay, I just stop. No cycle was found. Cycle is just, I just put it like this, right? A complete path is made here. From I just move from here to here to here, stop. I move from here to here, stop. I move from here to here to here to here to here to, oh, now I could say, okay, I found a cycle. So here the cycle is only here, not here, not here, not here, not here. Thus there's a difference between a directed and the undirected graph. Now you will say, Aryan, what's the difference? So basically, if we just recap what we did in the undirected graph is, we were just doing a simple DFS traversal. We are visiting every node at every step while traversing a path. We were visiting that node. If the node already visited and it is not my parent, then I'm going to say, okay, I have found a cycle. It is what we saw the last video. But here you will see that why the same thing can't be applied. Why? See, why the same thing? Which means if the node is already visited and not the parent, it is, which we are visiting right now, it is going to be visited, which is already visited and is not my parent, then I will say it is a cycle. But it is not gonna be useful in this, because if we just start from this 0, then I just go on visit, it is visited, is it visited, it is visited, but it is DFS is still remaining. So next time it will just go on visited. Visit this, okay, it is already visited, so it will just go down and visit this. It will next try to visit this thing. It is not its parent, because its parent right now, three parent is right now 0, but it is going to visit this particular thing which is 2, which is not its parent, and it's already visited. So you will say, okay, you have found a cycle, but no, you have not. It is not a cycle. It is just one path from above, one path from below. That is the reason that you can't say that it is visited, that it's having a cycle, because they are already visited but from a different path. Remember, if it would have been visited from the same path, because if visit, if it would have gone above, visit, then I would have said, okay, it is visited in the same path. So I will say, but it is not. It is something like this. I just move pink wise from here to here, one path. I just moved light pink wise from here to here, from 0 to 2, another path. If I would have said, okay, it is visited in the same pink path, then it would have been visited. But in this case of orange path, you will easily see that, okay, it is visited from 4, 5, 6, like this. It is in the same path which is visited. Green one you will see, okay, it is half path which is visited, and the white one is the again half path which is visited, not a complete path which is visited. Thus you will say it is not a cycle. We have to do the same thing. We just have to monitor as soon as we come back. Okay, we traverse from path, although we want our traversal to be one time visited, which means if I visit this node once, I have to say, okay, I visited it, I will never visit that node again. But I also need to make sure simultaneously that I don't want to monitor that particular node if it is visited in a different path. It should be visited in my path. So one thing I need to make sure, okay, it needs to be visited to actually, I need to mark as a variable or as an array as visited, that to actually make sure that the node right here, I visit it exactly once. And I also simultaneously thinking, okay, but I also want that node should only be visited in my path. So let's have something as path visited. Although you can do the same thing by coloring, multiple coloring and all that stuff, and do a backtracking in DFS and all that stuff, but it is the easiest way to visualize this. I'm not making it more critical because it's actually like people just forget about multiple coloring in a graph, because it's another way to find, okay, it's a directed cycle or not. But I'm not saying this right now because I just want you to remember the concept. Okay, what was the issue initially? We wanted a node to be visited but in my path, but actually parallelly I also wanted a node to be visited that I don't visit that again. That's the reason I just took a visited and a path visited, which means I will just make sure that if I just visit this, okay, it is visited, but it is also a path visited, and path visited. Now next time when I'm gonna move back, which means as in DFS you just go back, so as you move back, so you will erase that path visited, now as you move back to this 0 to this next node 3, now it is visited and it is also path visited, it is also path visited. Thus you will say, okay, it, as you move on to 2, it was already visited, but it was not path visited. Thus visited, which means you can't go on to that node. Path visited, which means it is not the cycle, because path visited is not here. That is how we're gonna see, okay, if our node, if our graph is having a cycle or not. Let's see. Let's have a dry run on this algorithm and see how we're gonna find it. So basically, let's start with dry run. The input graph is exactly the same. Here you will have the adjacency list. As you will be given the question, if you don't remember adjacency list, go and watch the graph lecture 2. It will have exactly, okay, how the adjacency list look like. It just says, okay, for the node 0, I have the neighbors as 1, 3 and 4. You can see 1, 3 and 4. As I said, to find, okay, if I have a cycle in interactive graph or not, I need to maintain two things, which is visited and path visited. Visited is to make sure that I visit every node exactly once. Path visited is to make sure that if I am gonna go on a node which is already visited and is not my parent for sure, then if it is also path visited, which means it's a cycle, but if it's not a path visited, then it's not a cycle. So path visited just to make sure, okay, is that node visited in the same path as me or not? At a point of time, any number which is 1 here will show, okay, it is one path which is going on, right? And we will see much better with the example itself, the dry run itself. Now, as we start off with the first node 0, cool, I will just mark it as visited and also path visited, right? Now I have 3 options to move, either 4, 1 or 3. I can, from a DFS of 0, I can go a DFS of 1, 3 and 4. Okay, it will just firstly go to the DFS of 1. What will happen? As it go, it will just mark it as both visited and path visited, and path visited. Cool, because it is visiting in the same path itself. Cool. From 1, I can do a call at 2. It's the only call I can do. Okay, I'll do another call, which means I will again visit it and path visited. Okay, cool. Visited and path visited. From 2, I can't go anywhere because it has no childs at all. So okay, I have not found a cycle. Still I have to try again and again. I will just go back. Back in the sense, it is done. I can't go further here. So what I will do is I will just go back. But while going back, I need to make sure, okay, my path is being changed in future. I am going back. But I also need to make sure, okay, it was visited one time, so it should be visited. So its visited is intact there, but its path visited is being removed while it is going back. So as it is moving back, its visited is intact, but the path visited has gone because I am now changing my path. I came here, now I am going back somewhere else. My path is changing. That's the reason I am removing that path visited thing. Cool, no worries. Then from as it moves on, okay, one will come, then again 1 will go because it is just moving back It came from 1 to 2. Now it is just going back to actually do again a DFS traversal to again of its next nodes. Cool. Then you will see from 1 what happened. It's 1 is visited, it's intact, but its path visited is gone. From 0, I had again option to do a DFS of 3, which means I will visit that node and also make it as path visited. Visit that node and also make it as path visited. Now again, next what will happen is I will just go on. From 3, I can go on to 2. But as to 2, I will see, oh, it's already visited, which means I can't go to 2, because if a node is already visited, we have said that we visit every node exactly once. We can't visit a node again and again. So if it is visited, we can't go on it. Is it that I have found a cycle? I will check that thing with the path visited. Is the path visited also 1? Which means I have found the same visited thing in the same path. Oh, no. Path visited was not 1, which means it is not 1. If it would have been 1, I would have said, okay, I have found a cycle, but it is not. So I have not found a cycle. Cool. No worries. I will just again go and back. Go back. Okay. It was already path visited is 0. As it moved back from 3, again, it will just do a path visited of 3 as again to 0, because now I'm changing my path. So path is not visited now. Cool. Now from 0, as we said that we had 3 options, 1, 3 and 4. So now I will just go on to 4. Cool. From 0, I just go on to 4. Now, okay, what will happen is it will just get visited because now it is visited, and also path visited because it is visiting the same path itself. Cool. No worries. From 4, I have option to go to 5. It is the only option I have. So no worries. I just visit that and also path visited. Cool. No worries. From 5, I have option to go to 6. Cool. No worries. From 5, I will go move to 6, which means I will just visit that and also path visited. Now from 6, I have option to go to 4, but I will see 4 is already visited, so I can't visit that again. Is it that I have found a cycle? Just check by path visited. If the path visited is also 1, which means I have found the cycle, I have found the node visited in the same path. Visit in the same path, which means I found a cycle. Oh, I found that 4 was visited and also in the same path, which means I have found a directed cycle in my graph. That is how you're gonna find a directed cycle in your graph. Simple, exactly same. It's just that the only operation you have to do is you have to move on to your neighbors. And firstly, you have, as we initially can see, our graph is one component right here and one component right here. Thus, we will just find the cycle in the entire graph, which means in every component. So I have to go on and do a DFS traversal on every unvisited node. That is, we saw in the undirected graph video also, that to find a cycle in directed graph, we have to actually go on to the entire graph, and graph can be multiple components. That's the reason we just do a DFS traversal on this entire graph, which means entire node doing a particular DFS. Now, at every DFS, I just do one thing. I just firstly, as I land onto a node, I just mark it as visited and path visited. As I am going on to the next neighbor, if that node is never visited, I will just go and visit that node and also make it as path visited. I will just go, if it is not visited, I will just go and visit that node, right? If at any chance, if I'm going on and if I landed, let's say at 3, now the next node is visited. Here the case was it is not visited, so I simply visit that node. Here, if the node is already visited, then I just need to check one thing. Is that also path visited or not? If it is path visited, I will just return a 2. I have found a cycle. If it is not path visited, I will say, okay, no worries. It is not path visited. No worries. Just move back, and also while moving back, just make sure while moving back, right? When your process is done, while moving back, just make sure that you put your path visited as 0. That's the same thing which you want to implement. Let's see the code pretty easily. Firstly, we have our main function. Just another big thing, just mark this code as a snippet. It is very important. It can be asked as a sub problem. Okay, you will be given a graph, and in a programming contest it will be said that okay, just a sub problem of that particular graph problem can be just have a cycle in a directed graph. So the codes are down below for both C++ and Java. You can, if you are studying Python, you can also convert that code to Python. It's pretty easy. Just that mark this entire code as this snippet, and that will be very useful for you. You can just copy paste this code from the PDF down below. PDF is down below exactly like this. Now, as we go into the code, firstly, as we know, okay, we need to have two arrays, vectors as path as visited and path visited. We know why we want these two as. Now, as I said, I will go on to every of the vertex. Why? Because our graph can be made up of multiple components. So I just need to evaluate every component of a graph, that is there a cycle in every component or not. Then, if it is not visited, which means earlier it is not visited, then I will just run a DFS traversal on that, which is exactly this thing. Cycle in a directed graph, it will just do a DFS traversal and find okay if there is a cycle or not. If I found a cycle, because it will return a true or not, true or false. Cycle in directed graph will return a true or a false. If there is a cycle, then I will return a true. And as we go on to every component and could not find a cycle, then ultimately I can return a false. Ultimately, after evaluating every of those component. Now, as this function is being called, so it is a main function for sure, we should say. Cycle in a directed graph, it will just find okay for this particular component right here, is there a cycle in this graph? So basically it will just go on, and in this it will just say, firstly, as we land onto a node, our first condition was to mark it as visited and also path visited. Just mark both of them as true, because now you have visited that node and also path visited that node. Now the next operation was you just go on to our child. As in the case, we from 0, I just went on to 1, 3 and 4. As we go on to child, we had again two conditions, as you remember. If the child is from 0, I was going on to 1, 3 and 4. If our child is not visited, then no tension at all. Just visit that. If it is not visited, then no tension at all. Just visit the child. But as it's DFS, and we saw in the last lecture also, as it's a DFS, and we want okay, if ultimately maybe my child finds some cycle, so it should return a true that okay, hey father, I have found a cycle. You just say okay, you have found the cycle, because ultimately if my child finds a cycle, so I have also found a cycle. So that's the reason. If my child finds a cycle, which means my child is returning a true, so I should also return a true. That is, I am also returning a true if my child has found a cycle. Now the next condition was if the child was already visited. Now here I will just check if it is visited. If my child is already because see, if the child is not visited, it is false. Else condition will come if the child is already visited. But here also I need to check. Okay, it's visited, but if it is also path visited, then only I can say I have found a cycle. Else I cannot say anything. So I will say okay, if it is also path visited, then I will say I have found a cycle, and I will do the same operation of trying to find a cycle for every of my child. Cool. And ultimately, as I move back to my parent, as I move back, right, as I said, as I move back, because here I just landed onto my node, I just went on to my child's, now I am moving back. As I said, as I move back, I need to make sure that I put path visited as false. Here you will see path visited as false. Thus ultimately, if anyhow doing everything, you are trying on every child and no child is returning true, no node is returning true, ultimately you have to return a false. That is how you will say okay, no cycle was found. Here it just landed, it will just return a true and it will just say okay, cycle was found. That is how you will do this problem. It's pretty easy, pretty standard, pretty same as that of the undirected graph. It's just that you just have to change these two stuff, which means path visited you need to maintain, and also you need to just maintain okay, path visited is true, then you should return a true, and at last also make sure that you just make that path visit of that node false when you are moving back. Here the operation is done. Here you just move back. Here you just go in. That is how recursion works. Now, the complexity, as you can see, that we are visiting every node and edge exactly once. Thus, the complexity is v plus e. Space is nothing but vo of v, because you are using visited and also path visited. As I said, the code of C++ and Java exactly. You can just copy paste from this PDF. It's copy pastable. You can just copy from here and mark it as a snippet. I hope that you guys got the problem. Okay, how it's a difference between, please always try to link this with the undirected graph, because there's a high chance in future you will remember the undirected graph to find a cycle, but you will forget the directed graph how to find a cycle, and it's very important for interviews. So yeah, that's all from me, and I hope that you guys liked it. If yes, then do the like button. See you next time. Goodbye, take care.